So I'm Stuart McIrvine. I've been around for a long time, very long time. I'm tired. I really am. I've been in the industry just a little over 30 years now. Obviously I'm with Broadcom CA. I've been with Broadcom CA about 3 years now. Before that, I was with HP. And I was with HP when it kept splitting and splitting and splitting, and eventually I thought it's time to get out, right, before I end up being one of the little atoms that gets split during that whole process. So I was there for about 6 years, and then before that, the largest part of my career was with IBM. So I was with IBM 21 years, so right when I was a little baby, I started with IBM, all sorts of jobs over there. But, I say I'm tired. I've really enjoyed it. I've loved, information technology, and it still continues to be a fascinating area. My responsibilities extend into both security. So I'm focused on mainframe security right now. I have the product management for all our mainframe security products, as well as the whole intelligent operations space. And this is what I'm going to focus on today. But the first thing I want to just have a little blurb on is Broadcom. Everyone, many of you now who heard of CA Technologies, right? Give me a little hand. Lovely, thank you, well done. Now Broadcom, who had heard of Broadcom beforehand? Okay, that's pretty good. Well, so Broadcom is big, very much hardware-oriented, semiconductors, a lot of devices. Broadcom is certainly very big in the data center, which makes it very relevant. They see the growth of the data centers, but not so much in the software. A lot of software, around the devices that they build and sell. But they really saw the value, certainly obviously they see the value in the data center, but they see value in software. So wanted to get into software. They saw what we were doing with mainframe. They still, as we do, I keep saying we and they, we're all the big we now, the Broadcom, CA, we, right? But they saw the value in the data center, the value of the software, but particular interest clearly in the mainframe, and that's a space I've been around for a very long time. So this was what really triggered the investment here. It has been great, and I'm not just saying that. You probably think, he works for the company, he's got to say that. It has been tremendous as we've gone through the early stages of this acquisition to see the level of investment they want to put in mainframe. That's good for us. It's good for me being a product manager. I get to spend more money on my products, but it's also tremendous for our customers too. So good so far. Let's come back in a year and I'll tell you how it's going then. So this whole area of intelligent operations, right? I didn't realize this was a build. Let me just throw this here. So let me kind of just start off with a little bit of the whole problem space, right? What we're dealing with, and this comes from various different reports and surveys, etc. But the volume of data that we have to get through to understand a lot of the operational issues that we're dealing with is enormous. It's growing. It depends what report you look at, but it's growing at 88% a year. And then through some of these reports and surveys, the average mean time to recovery is about 4.5 hours. Okay, these are typical large organizations, but that's a problem. I have one client, I can't really mention their name, but I was talking to them fairly recently, and they were telling me that on their mainframe, an hour of downtime equals $6 million, right? So 4.5 hours mean time to recovery is a very, very expensive proposition. So we've got to get that much, much shorter. And some of these, outages are big. I think the 150 million we're talking about here, Delta had a big outage, that cost them 150 million. Even Amazon Prime, their Prime Day outage lost them, $100 million in sales. So point I'm trying to get is this is difficult and it's expensive, right? So that's what we're dealing with right now. Why is it difficult? Well, you probably all know, right? This is what we look like today, typical large organizations, right? It's a highly complex environment. We're dealing with hybrid IT now. Now we talk about hybrid IT, we talk about hybrid cloud. The main difference, hybrid cloud is really a combination of public and private cloud. Hybrid IT It's everything, right? It's mobile, it's on-prem private clouds, it's using public clouds, right? It's all different types of systems that we use. And just look at it there, right? We've got web apps connecting in, they're touching structured and unstructured data. We've got physical servers, we've got virtual servers, et cetera, right? And all these, millions of pesky, mobile devices coming in, generating all this network traffic, right? And just like the network traffic you'll be generating right now as you're tweeting about my session. Don't say anything bad now, okay? But this is what, these mobile devices. So all this network traffic, but there are so many different domains that are being touched here, and it's highly complex environment, right? Way beyond us pure humans' ability to kind of process all this and really truly understand. And this is why you see these MTTR problems, et cetera. These kind of, long MTTR timeframes. So, as we look at this, as we map kind of that whole complex hybrid IT environment there, think of other aspects to it as well. We've got other things like DevOps and agile, right? We're trying to put new out apps in an agile fashion very frequently, new apps all the time. I think Amazon puts apps out, multiple app updates per day, right? I can't get my head around that one, right? But you look at the velocity in the data center and the way architectures have to continue to change, right? The way kind of all these domains continue to change. As I said, the volume of events, the different types of data that we're having to deal with and having to bring in experts all the time to analyze this, right? And bringing these experts, their time is expensive. We're taking them, this is not their day job, right? To go analyze, potential outages or root cause analysis, et cetera. We're taking them away from their day job to be able to do this, right? So, with all this complexity, the velocity of change, the volume of data, everything else. So how do we do this today, right? Well, the way in which we're handling this today is we have our experts, we have our monitoring tools that sit inside all their specific domains. You can see here we've got, network monitoring tools, we've got storage monitoring tools, systems monitoring tools, et cetera. That's all well and good, but the problem is, in order to find out where a lot of the problems are, or to understand that we even have a problem in the first place, we have to understand perspectives across multiple domains. It's not just within those domains. And even pick, for example, one of them is even within the network domain, you see I've got listed there fault and performance, right? I get people looking at, fault analysis, and then people looking at network performance, right? Let's pick a simple situation, right? I do have a network fault. I'm just, a router's gone out, for example. Now what happens then? All the traffic's going through another router. So the performance guys are going, uh-oh. Or I'm starting to see poor response time because all the traffic's going through one router. So everyone's starting to point to that router. But there's nothing wrong with that router. It's just handling the traffic from the other one that broke down, right? So it's having to understand the big picture. And that's just within one domain. Right, now I start to build up and look. Now I've got to look across other domains. I've got the applications, right? They're transactions, right? These transactions are touching, other applications and storage and databases and everything else, right? So when I start to see application response times, and down on the experience analytic, very important area, we're looking at end users. What are the response times they're experiencing, right? Because we've all become extremely impatient, right? We're not as impatient as our kids, right? Because they grew up with these little devices that give them everything instantly, It's like their parents give them everything instantly, right? But we're very impatient. Response times are critical, and this is this whole area of experience analytics, right? Measuring this. But, trying to understand what is causing that response time? Is it the database? Is it the network? Is it just poor application performance, et cetera, right? So that is, another area we've got, and quite often when we hit these really tough problems, right, Yes, we understand what's going on in the network. Yes, we understand what's going on from an infrastructure, user experience perspective. We still can't find out the problem. So what do? We set up a bridge call. We bring everyone together, right? And then we try and figure out, we got all the experts, right, talking to each other. Again, just like I said before, wasting a lot of their time, taking them away from their day jobs to try and figure out exactly what's happening, right? This is what we really need to get away from, right? Let these experts kind of do their job. So where are we moving to? We're moving to this area, and this is a term that was really kind of coined, I should say, by Gartner. AI ops, right? So it's bringing machine learning, artificial intelligence together, right, across the data, right, from all these different domains. Right, having the ability to correlate the data across these domains, right, and gain insight, right, understand using machine learning and artificial intelligence to truly understand the root cause of the problem. Not just what we're doing today is I can see a whole bunch of symptoms, right, but try and understand where is this, where's the root cause actually happening. Right, and I'm going to go into some more detail on how we actually go about that, because it's a lot of it is a process, but this is a real area, right? This is something that, as I mentioned, Gartner, Gartner coined it, and Gartner is dealing with frequent client requests in this area. I think they've received well over 500-600 client inquiries in this specific area. And as Gartner does, and as Gartner does very well, they're making predictions that by 2022, 40% of organizations, right, will be using artificial intelligence, in this particular space. More stats, right? This comes from Sloan Business School, as well as I think there was an Adobe document as well. But just highlighting that pretty much most organizations are investing in kind of building and launching big data, artificial intelligence initiatives, and nearly half of large organizations today actually have a very well-defined strategy in this area, right? So I'm just trying to say that this is pretty real, okay? So what is this kind of intelligent operations, right? What is needed in this particular area? So the left-hand side is what I've been talking a lot about, is all these different domains, right? We've got experts in each one of these domains, whether it's systems, network, application, blah, 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 etc., right? We've got our experts in there, and we've been dealing with the bridge calls, etc. So what we're doing is these domains produce incredible amounts of very useful data. They also produce incredible amounts of useless, irrelevant data. Let's call that noise, okay? So the whole idea is to bring a lot of this data in. The first stage is to really correlate, right? Start to normalize a lot of the data that's coming in from the different places. This is different types of events and everything else. Try and get it into, a meaningful set that we can analyze, the ability to kind of correlate all these different events, etc., right? The other piece is to start deriving insights, right? So then, we're starting to look at, we've pulled all these events in, right? Now I've got to start saying, I've got to start filtering out some of the noise here, right? I've got to start identifying which are, and I'll go into some of the much more detail in each of these areas, but, which ones are relevant, which ones, which ones are just noise. So filter out the rubbish, right, let's say, and start to derive insights from this data that I'm truly gathering. Now I've got to apply context. Now what does that mean? So context, there are many different contexts here, right? Some of it could be, okay, I've got to look at this particular error in this domain against what's going on in the other domains. It's not looking at domains in isolation. So that's a big part of the context. Other parts of the context could be just environmental conditions that will happen. I've just deployed a new app, right? And things went nuts, right? And in the past, sometimes I've deployed a new app before and things went nuts. Another context could be the time of year, right? I'm a retailer and it's Black Friday. okay? Or I'm a retailer, it's the holiday season, right? So context is critical here, because on some days of the year, or based on some events that have happened, right, I should expect to see some spikes, right? Or, now sometimes that can be normal, sometimes it could be abnormal. Let's say I deployed an app and it's a bad app, right? But I've seen this before, and I'm telling you now, when I saw these certain things happen, it's looking at, gathering a lot of the historical data and understanding, when A happened before, followed by B, then C happened and everything went, into the toilet, into the trash can. But, when I saw that, so next time I want to start looking at, well, A's happened and B's happened, C's probably going to happen. I need to start flagging some alerts and things like that, right? Identifying where some of the problems are. So context is very critical. Being able to bring all the alerts together, get some insight from that, even deeper insights by applying the context. And then, of course, this last area is, as we start to get much more advanced, starting to help remediate some of the problems, right? Automate some of the action. Now, this can be relatively simple at first, right? Nobody wants to be really gutsy and have this completely self-driving system today, because one, we don't trust it. So in certain basic situations, we may want to kind of automate some action, because we know when this problem happens, it's definitely this kind of situation, and this is the typical scripts or whatever we run in order to remediate that. And as as our information, as our data, as our insights get better and better over time, we get a little bit more confidence about some of the automated action that we actually take. So now what I want to do is just go into a little bit more detail in some of these areas and how we do it, etc. But before I do that, I like I like this whole idea of the self-driving car, because it's actually a good analogy, the maturity model around how we're evolving these self-driving, or the car from being this manual thing, like I drive today, because I drive a pickup truck, right? That's not exactly self-driving, and then all the way through a maturity model to a truly self-driving car. And this basically comes from the Society of Automation Engineers. So this is their definition. So way at the kind of bottom end of the scale, you've got Stuart McIrvine's truck, right? Pretty manual transmission, poorly driven because I'm at the wheel, that kind of thing, right? Then we get on to kind of level one, where you've got, blind spot warnings and stuff like that. I got to say, this is one that I actually do not like, blind spot warnings, and I don't like it for one reason. My wife's car has it, and when I get in there, I get too used to having it, and then I get back into, of course, my pickup truck, which doesn't have it, and suddenly, I'm not as good a driver anymore, right? But things like that, and kind of when should you shift gears? So that's kind of the next stage. So really I look at that as, first stage is manual, next stage is I'm getting notifications to kind of help me be a better driver, right? And then we start to move to level 2, which is a little bit of kind of partial automation here, right? We've got adaptive cruise control. So I'm driving along and suddenly it detects there's a car in front of me, it starts slowing down a little bit more, right? Emergency braking. This is, critical emergency braking for, if those times where you just have to, read that text message or write that text message, right? I'm kidding, right? Seriously, that was probably not even a joke. But having emergency braking, when you're starting to drift in and out of lanes and stuff like that, right? Then we start to go on to level 3, right? This is where we start to get a little bit more than just conditional autonomy here, right? Now the car is starting to park itself, give me a lot of assistance on the highway. When I go around bends, it's adjusting speed and things like that. Level 4, this is where really for certain predefined routes, the car can drive there. Has anyone seen any of these cars? Have you been in Vegas and have you seen these autonomous cars that drive? They still have drivers in them, and they still have all the controls, right? So the driver can take over. But for certain, from going point to point, they're actually pretty good at getting there. I don't know if I'm ready to go into one yet, but does anyone drive a Tesla here? Anyone got a Tesla? Oh, good. I don't need to be resentful and jealous with any of you. But one of my colleagues at work, he's a friend as well as a colleague, he bought a Tesla last year, and he took me out in this thing. And usually I'm not that impressed with technology. We all kind of live and breathe technology every day of our lives. But that is an impressive car. He was driving along, and he put his turn signal on, and that car waited. That Tesla waited for a gap in the traffic and then just moved itself out. He wasn't even touching the wheel. Can you believe that? Yeah. But anyway, so you know, Tesla's fairly far along on the maturity curve here. All right, but then you got point to point, and then of course the autonomous driving, that's truly autonomous. You know, when you talk to the big car manufacturers, you know, we're still at least 10 years away from that. But that's where you don't even have the controls. You can't take over. The car is doing everything itself. You know, you put in your GPS location and off you go. So that's your car, and it's a good model, right? Because you know, underneath that, I'm looking at, you know, where we are with, you know, with IT operations, our data centers, how we're managing that, and where we want to really get to in the future, right? Having this really eventually this very autonomous data center. So level 0 is the manual reports. And I'll go through what that looks like, but this is, you know, the swivel chair management, you know, different screens for network management and all that kind of stuff. Still trying to correlate across the domains. When we get to level 1, that's when we start to, you know, get things like we can detect anomalies, right? We can understand, you know, through intelligent operations when things are going wrong or they're starting to go wrong and stuff like that, right? So it's basically saying, you know, yeah, something's going to go wrong here. We're starting to see some anomalies. Level 2 is really starting to get to not only do I understand something's going wrong, but I can help you find out what the real root cause of the problem is. It's not just telling you about a lot of the different symptoms, right, that are appearing. Level 3, this is now starting to get, you know, what we call learned remediation, right? So the system's learning more. It's actually learning from the experts too, and I'll talk a little bit about that, right? But it's also starting to kick off some remediation. So it's not just notifying you something's going to go wrong, right? And it's doing a little bit more than the root cause analysis. It's actually trying to, in some simple cases, you know, remediate some of the simpler problems. And then this level 4 area, this really kind of the self-healing operations, that's starting to now look at, okay, so I found the root cause for you. You know, I've done some remediation for you. I've told you, here's what the root cause. You've done some remediation. I'm going to learn from that because I'm going to look at the logs, right? I'm going to look at what you did to remediate this problem, and I'm going to look at the outcome. And did it fix it, right? Did my performance start going back to normal, right? Did my response times improve, all these different things? So as a system, I'm going to learn from that. So I'm taking the outcomes now, and if it didn't work so well, okay, that's not going to be something I log, right? But really kind of learning from that, using the outcomes to understand, am I going in the right direction? Should I use that as a recommended remediation the next time, etc. And then level 5, long way off from level 5, but that really is kind of your lights out. This is your lights out, self-running data centers, you know, and you know. We're all out of jobs, but we're all going to retire anyway, right at that point. So that's really kind of looking at the maturity, you know, model for this against what we have with the self-driving car. So that level 0 that I talked about, this is where we're very manual, right? This is looking at this sea of red. You know, all these alerts come up. Most of them are noise. You know, I think IDG threw a report out that said 31% of all this data that we're looking at is just pure noise. It's absolutely irrelevant, right? And the problem with that is it just affects productivity, right? We're looking at noise, and not only is it affecting productivity, because we're having to figure out, you know, is this just noise or is it real? But we're getting desensitized, and we know this is true, right? Everyone's looking at, we're seeing these noisy events, and it's taking our eye away from some of the real problems. Or it's saying, sometimes when you see the real problems, you know, this is probably just more noise, right? And all of this is affecting, you know, our mean time to recovery. So now we start to get up to level 1 here. And what we're doing in this space is we're applying some algorithms now. And we've got a couple of algorithms, but the key here is to start to collect historical information, to set up a profile for what your data center looks like, for what system performance looks like, etc. Right? So really kind of understand this profile, because this is what we want to start measuring against, right? To understand when we have certain anomalies, right, to standard behavior. So this is kind of a standard behavior, let's say, profile. We have a couple of core algorithms in here. One of them is really what we call exponentially weighted move rate average. That one is critical because you don't necessarily have to want to wait 6, 8 weeks, half a year to collect enough information to build this profile, right? So there's some out of the box capability you need, and this one's looking at really volatility. So it's kind of exponential volatility. So if you have a fairly volatile system, that's okay. But if you see sort of some, exponential changes based on that volatility, you're probably starting to have some kind of problem. So you don't necessarily need all this historic data to get started here. But what it gets you away from are these horrible static thresholds. We know we've got these static thresholds set today. Once I start to go beyond a certain response time, everyone in, right? Try and figure out what this problem is. But as I say, it could be Black Friday, right? And this could be normal for several hours and things like that, right? So that's one part of it. Then there's another, set of algorithms we use, which is complements this, and it's very much looking at historical data. So this is where I say you're building up this profile. You're adding in things like, Black Friday, the holiday season, right? Certain times of year, where, you get big orders coming in and all this kind of stuff, large sales volumes, right? So it's building up your profile, right? And then starting to understand what is anomalous behavior against that profile. Again, getting you away from this static threshold, setting more dynamic thresholds so that you're not dealing with noise or, unnecessary events all the time. So how does this work? So what we use here is we actually use the Western Electric rules, and this kind of slide here quite simply shows it. Now, I'm horribly colorblind, so I should have basically changed the colors on this. But I hope anyone in here colorblind? You are as well. Can you see the different shades of green there? You can. Oh, you're a lot better than I am then.
But there are different types of colorblind.
Yeah, there are. You're absolutely right. I'm kind of every type, right? I'm just horribly colorblind, but there are. So there's a very dark green band in the middle, and I can actually see it. Actually, this is quite a good screen. I can see it reasonably well here. But what we're doing here with these Western Electric rules, if you're not familiar with them, is that kind of black line that's running through it, that's kind of your mean behavior of your system. This is where your performance goes across the timeline, different times of the year, etc. Right? The dark green band that's closest to that, that's around that, that is the one, okay, if I get all my points, my performance points are within that band, I'm probably pretty good. Right, that's my margin of error that I'm prepared to deal with. That's kind of the adaptive thresholding. That next lighter green band, that's the now wider. Okay, what happens if I have 2 out of 3 of my points are in there? I'm probably going to flag an alert, right? Because 2 out of 3 is starting to get sorry, I beg your pardon, I got the wrong way. 4 out of 5, go outside of that very dark green area, I probably got a problem. If I have 2 out of 3 into the next area, right, then I'm going to flag an alert. And if I have even 1 that goes into the white space, yeah, I'm going to certainly flag alerts, right? So this is basically how we're highlighting these anomalies. So it's a combination of understanding the history, what's going on for your organization, right? And then starting to look at how far away from the mean, right, am I before I start, flagging alerts and things like that. So that's one key part of what we're doing there. Another thing that's critically important is reducing this noise, because you have so many events. You know, I quoted that figure from IDG, 31% of these events are just pure noise and irrelevant, right? So another part of what our algorithms are doing here is it's just noise reduction. It's looking at when you get a whole bunch of duplicate events, right? You know, taking them away. You know, it's the same thing. We're using text analysis and stuff like that to remove a lot of duplicate events, right? Or symptoms of the same problem. So a lot of noise reduction there, because that's one of the things that's critically affecting, you know, the productivity of all of us. So that's a big focus area here. And then, you know, the other thing that's going on here is, again, starting to look across domains. So it's not just saying I've got a whole bunch of duplicate events. I've got, you know, networking response times, you know, storage problems, right, application problems, all happening at the same time. I can probably cluster them together, right, and highlight, you know, I've probably got the same issue here to try and kind of help. So it's enriching some of these events, right, into, you know, dare I say it, incidents and stuff like that, right? This is a big part of reducing the noise. So I can not just get rid of all the unwanted events, but I can start to look at where do I see real problems in multiple domains that are highly related, highly correlated, and get you to focus on them first, right? Which is a big part of the noise reduction as well. Then we start to get into the root cause analysis, right? This is kind of one of the tougher areas. What we're doing here is we're using machine learning. Let me back up a little bit. So one of the problems that I mentioned way back at the beginning is our environments are constantly changing. You know, if you're agile and you're deploying new apps all the time, architectures are changing and everything else. These are very dynamic environments. So therefore, you bring out a new app and it accesses, a database, right? It integrates with other applications in the system, all as part of your system. The dependencies are constantly changing. So a key part of what we're doing here is to use machine learning to start to understand dependencies. This particular application, what does it do? Does it access certain ports in the network? Does it touch databases and other storage repositories, et cetera? So dynamically understand the topology and build you a topology map, right? So that once we start to see certain problems occurring in certain areas, they go red, right? Now I can understand, well, this app's going red and I see it's dependent on this database, which is also going red, et cetera. So this is now is doing this, dynamic dependency mapping, right? And building you this kind of topology picture that they can then use to do drill downs, et cetera, to understand, where some of these, where the root cause of a lot of these problems are. Taking it a stage further, learned remediation. What does that mean? What does that mean? What learned remediation is, and this is always I look at, I remember, I think I can say this without getting in any trouble. My previous employer, right, if you've got good memory, you remember who that is. They actually had a very, very good product when they were in the software business. It was a security information event management platform. So it would kind of understand, it would have a lot of intelligence and understanding when they truly had a problem. They had another product that would try and remediate that problem. If I got a denial of service attack, I would go start shutting down ports and the firewall and all these different things, right? The main product that did all the analysis, they had a massive customer base on that. Many customers bought the other product that handled the remediation. Nobody ever used it, right? Now this is, I'm going back, 8, 9 years ago. And this is one of the areas we all lack the confidence, right, for a lot of this automated remediation, right? Because we lacked, let's say, a lot of the intelligence, a lot of the insights that we needed to get to the true root cause of the problem. Right? So when we get to this remediation stage, we've got to be confident that all the upfront piece that I've just been talking about, right, correlation and insight and, root cause analysis, now that we're starting to develop a good foundation in that area, this piece is starting to become much more realistic. Now, albeit today, right, you may do some simple remediations, right, that can be, let's say, very non-destructive, right? But this is important. Then, to help improve this area, I bring up this aspect of learned remediation. So what we're doing here is, as we get the insights, we understand, look, the system is bringing forward, here's where the problem is, here's what the problem is, this is kind of the root cause, and here's the recommended action. Now, I'm saying this recommended action because the system is looking at historical data when this type of situation happened in the past, and then looking at logs to see what action was taken, right, to try and remediate that, okay? And so then it's making recommendations. Do you want to do this? Now, it's making recommendations to the experts. And the experts, we use a sentiment analysis. The experts can give it a thumbs up or a thumbs down, and the machine starts to learn. Why is that important? Well, especially on the mainframe side, we've got a massive amount of expertise that's getting ready to retire, right? The more of this tribal knowledge we can capture, as we bring the experts in, right, I'm going to remediate this problem, or this is what I think the problem is, or I think it could be one of these three problems. Get the experts to give the thumbs up or the thumbs down so the system truly can learn, gather, ingest some of this tribal knowledge, and even start to, rather than you have to document it, right, start to build kind of documents, right, that say, look, this is what happened, this was the action that was taken, put that into documents, etc. So this is a very critical area, of learned remediation. It's bringing the intelligence and what we're doing, but using your experts as well to help the system learn better, right? And then this piece is what I briefly mentioned earlier is, now that we've executed some of these, remediations, let's learn from it. What happened? Did it solve the problem? Let's kind of start to look at the logs, right? Did my response time improve? Has performance gone back into that, nice dark green band again, et cetera? Or didn't it, right? But start to look at the outcomes, learn from the outcomes, again, to get more intelligence back into the system, kind of continue to use that feedback loop, right? To make the system smarter. Right, so this is the whole, the self-healing part is understanding these outcomes, which ones work, right, so that we know to use them in the future, and coupling that, of course, with what we learn from the experts. So let me start to kind of summarize. So, I told you up front the maturity model, where this thing goes. I went into kind of details in some of the areas and, how we do that, what we're doing. I just want to kind of summarize. It's like, one of my old professors at university said, tell them what you're going to tell them, and then tell them what you just told them. So this is what I'm doing right now, right? So this is what I've just told you, right? So we go in and we, the key area is correlation, basically gathering all this data from multiple different domains, right? Networking, storage, et cetera. And then based on that information, right, start to get some of the insights, some of the, the cross-domain dependencies, et cetera, right? Apply context, right? We're looking at some of the historical data that we've collected in the past. That's one part of the context. Some events that may have occurred, different times of year, right? The context again from other domains, right? So we're starting to bring all this together so that we've not just got a whole bunch of data that we've got partial insights into, we've got some real context to base it all on. And then, of course, drive action. And then one of the key pieces is, to learn from that action. Did that action actually do something, right? Just kind of wrapping up now. This whole area, when I talked at the beginning, why it's so complex, managing IT, understanding where problems are, et cetera. And it's costly, right? Our mean time to recovery, 4.5 hours, is pretty pitiful when you're losing millions of dollars per hour on certain outages, right? We've kind of worked with, a partner here to look at this type of solution and, that we're delivering and how it really does improve. And it is, driving results. I mean, you can see some of the results I got up here. Much faster, mean time to recovery, right? But 80%, faster at predicting problems, et cetera. You can see the results up here. But in general, it is significantly improving the productivity of employees. Our employees, let's say, our experts in these particular areas, and getting our systems back up and running, much faster, understanding and gathering a lot of that tribal knowledge from our experts that, that may be retiring. So let me pause there. First of all, thank you very much for your attendance. And let me see if you've got any questions.
Earlier parts of the maturity thing, what about helping us find out where the problem is not? Whereas as opposed, which seems like it's an easier problem than finding where it is.
Yeah. Well, I mean, so that, when we start to, if you remember the area I had where I had the topology maps, right? And this is where we're starting to show, okay, when I start to correlate different data together, right? Sometimes, the example I gave was, let's say, one of the examples I gave was on network performance versus fault, right? And everyone's looking at performance, right? And the reason performance was looking bad was everything was going through that one router because another router had broken. The real problem was over there, right? But the idea is using machine learning to understand when everything's starting to go through that router, right? I'm starting to see much greater traffic than I ever saw before, right? So this router is actually working and doing a good job. It's just handling much greater traffic. I have to start looking elsewhere in the system, right? So it's still looking at, are you operating within your guidelines and everything else, right? And if you are, and you're handling things, then the system's gathering data from other domains, right, to try and say, look, although everything looks like it's here, I'm starting to notice we've got other problems in other domains that are actually causing this, right? So that's kind of starting to look at where you're thinking the problem is, right? Because we're correlating from other domains, it's pointing to, the real root cause is over here. It's not here, right?
So I guess I'll restate my hypothesis. I've been on many escalations where we have 96 experts, probably sometimes more than that, and there's a hypothesis that I call spin the bottle debugging.
Right.
It must be the storage guys.
Yep.
Right. And now the storage people have to prove that it's not their problem.
Yep.
Right. Who knows whether it is or not. Right. But at any given moment, if I look across the fleet, I can probably say, if storage is giving me a green thing, let's not bottle them.
Right.
If the network things, maybe it's not green, you stay here. Those other apps, why are you here? Don't waste your time, right? You're green, right? It seems to me to be much easier to bisection the problem by saying who's good.
Right.
You go away first, right? And I could use some help to be doing that kind of. I mean, if every subsystem had a green light on, I guess that would be easy. But determining what that is externally I could use some help like.
Yeah,
this.
And it really comes down to the effectiveness of the root cause analysis, right? Because we've got 14 different symptoms, and everyone's saying, okay, you're one of the symptoms, you're the problem, right? And that's the power of the root cause analysis, because that's where you start to say, okay, right now I'm starting to see this is where the root of the problem actually is, right? And so it's not saying I'm focusing on where it's not. I'm trying to find out where it is, the root cause analysis part of it, so that I can then say this is where the problem is not, right? And it's separating that root cause from just a whole bunch of symptoms, right? So that's what it really, I guess, the kind of the answer to your question is having good root cause analysis is what, eliminates the where's the problem not piece.
How do you automate root cause analysis?
How do you automate root cause analysis? It's not really necessarily an automation area as such. It's a data analysis, data insight area, right? So, the idea behind it.
Grouping of events that happened at the same time, and then the human is looking at it, right?
So the humans are still very much a part of it today, absolutely, yes, right? So, but the idea is to try and get rid of a lot of the useless data that's out there, gather what's, what isn't noise, but what's critical is correlating across the different domains and applying the context, right? And then at that point, right, starting to say, and then understanding the topologies and the dependencies, right? So when the machine understands all this, right, that's now helping to say, okay, I understand that I have a problem here, it's not responding, but it's dependent on everything else, so I'm starting to get to the root cause, but it's really bringing this information up. You still get experts that, are saying, yeah, you're right, no, you're wrong, and stuff like that. Over time, that will improve, right? But yeah.
Thank you.
You're welcome.